My name is Ken Rowland. I'm a consulting software engineer working on HPCC Systems. I'm here today to talk to you about the new metrics framework as we move to the cloud. First, I'd like to talk a little about motivation for metrics. As we move to the cloud, the implementation in the cloud provides a lot of features that are not currently available in our bare metal deployment. For example, scaling through Kubernetes, monitoring, and recovery even, which is available now through the cloud. Monitoring is a critical part in understanding the health, performance, and reliability of any application or microservice in the cloud. As many of you know, as you move things further away from you, you can't really touch them, so you need new ways to know what's going on. Metrics provides that ability. Metrics are the foundation of an effective monitoring strategy, and I'm going to talk about today how we're doing that. And they really are part of a complete solution for system reliability engineering. One of the questions I always get when I'm working on this and talking about is, why do I need metrics? I already have metrics in my logs. So let's talk about that a little bit so you understand. Logs. Logs are very verbose. They're text-based. They're typically long. They contain multiple pieces of information, messages, values. They even have different levels which produce more noise around any metrics you may even want to see in the logs. They're large in comparison to metrics. They're generally created at logical points in the code. When a process starts, it stops, or when some state has changed. So they don't really account for varying conditions that change over the nature of what your application is doing. So they're really not true snapshots of state over time. They're really good at analyzing problems. So for deep drill down analysis, they can contain parameters, state, the path taken to where you are, and they can have descriptive messages describing what has happened. They're not easily actionable. They're expensive to query. Think about the multiple queries you might have to access in order to even get to the piece of metric data you wanted. So there's generally a lot of post-processing that has to go on. Metrics. Metrics are numeric. They're small. They're inexpensive to store and process at scale. Queries can produce large amounts of data for a single metric and allow you to add and manage those. They're easy to aggregate across the application and the cluster, and they can be actionable based on simple tests. Is this value greater than that? Has it gone above this value for a certain length of time? So the answer to that question is, you need both. I can best sum it up with this quote. To sum up the comparison, think of logs as lists of discrete events packaged and optimized for deep drill down analysis, while metrics are packaged to facilitate a continuous view of your environment and how it's changing over time and optimize for aggregate numerical analysis. So metrics tell you what's going on through a snapshot. Logs are good at figuring out what's happened. So let's talk about categories of metrics. The first category is red. Red metrics give you a workload-centric view of your application or microservice. They typically will measure requests. That measures the load on your application. Errors, how many errors are you having? And what's the cause of them? And duration of simple requests. All this gives you, in short, a measure of the responsiveness of your application. Use type metrics are service-centric and usually based on some kind of resource. Typically, you might think of those as CPU, memory, or network. Those are common examples. However, internally in your application, you can have your own resources that you want to measure. In short, these give you an inside view of what's going on inside your application. You measure utilization, saturation, and errors are typically the values that you would track. All of this feeds into system reliability engineering. These are 4 key metrics that the 2 above will help you measure for your application. Latency, which is your response time. Traffic, how much load are you under? Errors, what's happening and what's failing? And saturation, just how busy you are. So in order to have an effective metrics strategy, you have to have an effective metrics. So let's talk about that. Picking good metrics is imperative when developing and building a monitoring system. Good metrics all have these same characteristics. They are comparative. Is this number above a threshold? Has this average time exceeded the limit? They're understandable. The number of requests received is an easy to understand metric. The percent complete of active requests really isn't, because it doesn't give you any kind of measurable values. So they need to be understandable as to what they're actually measuring. They need to be simple values, counts, rates, a level. Those are really simple to look at and see what they mean. And I cannot express how important this is. They have to be useful and actionable. If you can't express how important it is, it's not useful. If it's not actionable, meaning you're not going to take some kind of action on it, it's not useful. Now, this doesn't really apply to develop metrics, because internally you may want to measure how long a particular algorithm is taking. But in a production environment, if you can't take action on that, it's not useful and shouldn't be there in production. Good metrics also change the behavior of your application. They allow you to scale based on load, resource usage, and those feed into the types of metrics I spoke of earlier, read and use type. They can help you scale your application. They can help create alerts. Is something going above something? A latency for some service or external gateway, is it increasing? Why is it increasing? This alert can tell you. Metrics can help you detect and isolate problems also. For example, if the response time for a particular service is going up, it could be the aggregation of several metrics. So inspection of those aggregated metrics can help you isolate what's going on. If the response time is based on or includes the latency of a service, external gateway service, you know, those aggregated metrics can help you isolate what that problem is. So let me talk a little bit about some of the goals we had with the framework that we put into HPCC Systems. One of the first ones is we wanted it to be agnostic from the collection system use. There are lots of systems out there. Some of the big ones are Prometheus, Elasticsearch, Datadog, and there's others as well. We did not want any of those system dependencies to work their way into where they didn't need to be. So the ops team needs to be able to select which collection system they want to use, and it has to be independent and agnostic to the components that are collecting metrics. We wanted to simplify component instrumentation and make it as easy as possible for someone to instrument their component to collect metrics. We want to insulate the component from collection and reporting dependencies. Every collection system has different dependencies, polled versus periodic, the way things are reported. We want to insulate the component from that. And we also want to provide a set of classes that can handle most of the stuff you have to do to implement and instrument your component. So let's give a brief overview of the framework. The framework consists of three main parts. The first is metrics. Metrics represent the primitives that components create to track component state. For example, the number of requests received, or the size of a queue, or the amount of time spent processing requests. These are individual measurements, and they are classified as such: a counter, a gauge, things such as that. They are created and updated by the component. The component creates each metric for each thing it wants to track, and then sprinkles the code throughout in order to update that metric to keep track of that state. The metric also handles synchronization between reporting and collecting and updating within the framework. Within the component, there may be two actors that need to access those values. The metric itself handles that synchronization to ensure that all the operations are atomic. Syncs. Syncs are the piece that are responsible for reporting values to the collection system. So they are specific to the collection system in use. For example, Prometheus, Elasticsearch, and Datadog. They implement all of the dependencies for that collection system. They are responsible for collecting and reporting metric values to the collection system. And this creates a pluggable architecture that isolates components and other parts of the system from the actual collection system in use. So we have, through this, achieved our goal of making the system agnostic to the collection system in use. The last piece is the metrics manager. Metric manager really kind of ties all of it together. It manages metrics and sinks, and also provides a set of methods and services available to the sink and the component for initialization and other operations. So let's talk about instrumentation of the component, which is what has to be done in order to collect metrics for the system. The first thing a component has to do is define a set of useful metrics. Using the use, read, and SRE guidance, you can define a set of metrics that are useful. I cannot state how important it is to make sure that metrics are useful. Then you add code to the component in order to collect the metrics. This consists first of creating a metrics manager singleton, and there's only one copy for the component across that particular application. Next thing that happens is that the component has to initialize the manager with the config. The config comes from Helm charts, and I'll talk about that a little bit later. So when that happens, the initialization of the metric manager, it will load and initialize the sinks that are in use. Again, the component is unaware of what's happening there. The component then creates the metrics it needs, useful metrics, and adds each to the metric manager through an interface. The metric manager then keeps a list of what's active. Then the component will sprinkle throughout its code updates to the metric. Generally, those are just a single line of code that may increment account, decrement account, things such as that in order to track the state of that particular metric. Then it tells the metric manager to start collecting. However, it has to do this before the mainline code begins in the component. Then it just goes along, the component just goes along its merry way, and in runtime just updates the metrics as things happen. Note from above, the component has no requirements for managing sinks. In fact, it doesn't even know which sinks are loaded. It doesn't even understand what the collection operation is. Collection is the process of collecting metric values and reporting them. It doesn't know about reporting. The sink is responsible for that. It also handles all the synchronization internal to the metric. So the component doesn't have to worry about any of the synchronization between the metric and its use by sinks when collecting and reporting. So what is collecting and reporting? Let's talk about that. The component first is responsible for enabling collection, and that's done prior to entering its mainline code. And that informs the sink that it's okay to start collecting. Prior to that, the sink will not collect because it's not finished with initialization. During runtime, the component has instrumented updates to metrics as part of its normal activities. So during runtime, a count gets incremented, counts get decremented, gauges go up and down. At some point during the operation of the component, the sink is triggered to do a collection. Now, the sink is triggered through usually one of two ways, periodic or polled. Prometheus, for example, is a polled architecture where the Prometheus service will actually send a poll request to the sink and tell it to collect its metrics. Elasticsearch is a periodic sink in that internally, every so often, it will go out and collect metrics. The sink queries the manager, the metric manager, for the list of metrics that it needs to collect. It then retrieves the value of each metric, builds a report, and sends it to the collection system. So let's talk about enabling metrics inside of the system. First off, all of this is based on the current chart inside our repository that the Helm is located at the Helm HPCC directory. Metrics are enabled via the values.yaml file. The following section needs to be added to the global section of that file. The section name is metrics. The first entry in that, well, the only entry really, is a sinks list. And this is the list of sinks that get loaded for metrics. Now, this particular configuration is applied to all components throughout the system. The first value inside of the sinks is the type of sink. Now, we have three sinks that we provide currently. File, which will write syncs, or sorry, which will write the log values for the metrics into a local file that you specify. We have a log sync that will write the metric values to the log file that the component is currently using. And we have a Prometheus sync that will provide metrics back to a Prometheus server. And then for each sync type, you provide a name and then sync specific settings. For example, for Prometheus, you need to specify the port number it has to listen to. For a file sync, you need to specify the file to which the metrics would be written. When we get to Elasticsearch, you would have to provide the IP address or domain name of where the Elasticsearch server was in order to write the reports. Or if you don't want to add the section to the values.yaml, you can provide it on the command line when you run the chart. The -F option there shows how you would point to a particular YAML file which would contain your metrics configuration. In this particular example, we're loading up Prometheus metrics. If you go into the Helm examples metrics directory, you'll find a README that gives you more information, along with some example files of YAML that you can use on the command line to enable metrics. Well, that basically completes my presentation. Here's some contact information for myself. Please feel free to send me an email with any questions you might have, and there's my LinkedIn profile if you wanted to connect with me. If you have any questions, please write them in the chat window. Thanks.